The power grid is a massive network that generates, transmits, and distributes electricity. It's like a vast transportation system. You can consider generation as highway start points, transmission as highways or freeways, and distribution as streets and lanes. Everything begins with generation. Power plants convert various forms of energy into electrical energy. This can come from traditional sources like coal, natural gas, and nuclear power, or renewable sources like wind, solar, and hydroelectric power. These plants produce electricity at high voltages, which makes it easier to transport over long distances. But how does this electricity make its way? So, transmission lines are like highways of the power grid. These high voltage lines carry electricity across vast distances, often hundreds of miles, from generation source to the areas where it's needed. The high voltage minimizes energy loss during this journey, making the process more efficient. These lines are interconnected, creating a web of pathways that allows electricity to flow across the regions and even between countries. The interconnectedness ensures that if one part of grid fails, electricity can be rerouted, keeping the power on. Once electricity reaches its destination, it passes through a substation. Here, the voltage is reduced to a safer level for local distribution. From there, electricity travels through smaller distribution lines like local roads, eventually reaching homes, business, and industries. This is the final leg of the journey, ensuring that when you flip a switch, the lights turn on instantly. But the power grid does much more than just deliver the electricity. The power grid is crucial to our modern day of life. It's not just about keeping the lights on, it's about managing the fine balance between supply and demand, integrating renewable energy, and ensuring that electricity is available at all times. Without the grid, each home or business would need its own power source, which would be inefficient, costly, and unreliable. The grid centralizes electricity productions and distributes it efficiently across entire region, making power more accessible and affordable. There are various types of power grids, each serving different needs. National grids cover entire country, integrating multiple regional grids into one unified system. Microgrids, on other hand, are localized networks that can operate independently, often used in remote areas or during emergencies. The power grid isn't without its challenges. As we move towards a more sustainable future, integrating renewable energy sources like wind and solar becomes increasingly important. These sources can be intermittent, requiring new technologies like energy storage and smart grid systems to manage electricity flow more effectively. The future of power grid lies in making it more flexible, resilient, and capable of handling dynamic demands of a modern society. So, next time you charge your phone or watch TV, remember the incredible system working behind the scenes to make it all possible, the power grid. It's an engineering marvel that keeps our world connected, and as we look to the future, it will continue to evolve to meet the growing demand for clean, reliable energy. If you found this video helpful, don't forget to hit the like button, share it with your friends, and subscribe to the Power Grid to learn more about fascinating world of electrical engineering. Thanks for watching.